Hello, this is Brady Chen. Today, I'm going to provide answers for some of the questions in Test 2 of CSC7013, the Advanced Math for Computer Scientists. And I found out that many of the students have some issues with the questions related to the deterministic finite automata, the DFA. So, so I'm going to pick some of the questions, the question 4, 6, and 7, and provide some of the answer keys for this. Okay, let's first look at the question 4. Okay, the question 4 says, build a DFA that accepts a string that start with 0, 1, 0. Okay, now, while there's no actually some kind of a standard format of doing this kind of problem, but there's an easy way to start this problem. So to build a DFA, we need to start from the starting state, right? So let's say, so the starting state is A, and it always comes with an arrow from nowhere. Okay, so that's the starting state. And now, since we are going to build a DFA that accepts a string that starts with 0, 1, 0. So in this case, we only have two import values, either 0 or 1. Okay, suppose the import value is 0. Now the starting state is A, but the import value is 0. Okay, now this is going to lead to another state. I call it state B. Now state B is one step closer to the accepting state, right? Because if we actually successfully get the string like a 0, 1, 0, then we're going to accept the string, right? So, so if it's 0, we're going to go to the state B, and B is one step closer to the accepting state. Now, if we are lucky enough, we got next import 1. So this is going to get us to state C, which is even closer to the accepting state. Okay, so let's first actually finish the case that everything goes smoothly. So we have an import 0, 1, and a 0 again. So now we got a string 0, 1, 0. Okay, now 0, 1, 0, of course, it start with, this string starts with 0, 1, 0, right? So then we get to the state D, and D is accepting state, right? Because we're definitely going to accept this. And also, besides 0, 1, 0, we're also going to accept any strings that starts with 0, 1, 0. So that means once we reach the state D, then it doesn't matter what's the follow-up import. So if the follow-up import is 0, so now we got a string 0, 1, 0, 0. And this string still starts with 0, 1, 0, right? So then we still can accept that string. So that means if the import is 0 after 0, 1, 0, we still can actually, stays in the accepting state. We stays in state D, right? And also for 1. So once we start with 0, 1, 0, 1, 0, it doesn't matter what's the follow-up imports. We always going to accept the string, right? Now that's the perfect path. Now for each state, like a state A, we have to actually think about all the possible import values. Now, what about if the import value is 1, not 0? Okay. Now, if we got a 1, import 1 starting from the state A, and we're gonna actually eventually land at the state, another state we call it E. 1 is a string, definitely it doesn't start with 0, 1, 0, right? So we're not going to accept a 1. And also, if a string starts with 1, there's no way that this string going to start with 0, 1, 0. So any string that starts with 1, it doesn't matter what's the follow-up value. So this string, we're never going to start with 0, 1, 0. So we're never going to be able to accept that string, right? So once we have import 1, then we're going to actually end up with state E, and that state, no matter what's the next import value, whether it's 1 or 0, it's still going to be landed in a state E, and state E is called trap state. The reason for this is because that string, no matter what happens, that string always starts with 1, so it's not 0, 1, 0. So it will always end up with the trap state, or sometimes called dead state. Now, so for A, if we have 0, import 0, then we go to B. So if we are at the B, that there's a hope that we're going to end up with the accepting state. But if we start with 1, then there's no hope. So it's always actually end up with trap state. Now, what about if the first import is 0 and the second import is not 1? It's also 0, right? Again, the second import is also 0. So now we're going to end up with a string like a 0, 0. So now, no matter what happens, whatever the actually follow-up import is going to be, this string going to start with 0, 0, not 0, 1, 0, right? So if it's 0, we're also going to land at the state E, which is a trap state. So if the string starts with 0, another 0, then this string never going to be able to be accepted. Okay. So that means 0, 1 is the only, the correct decision towards the accepting state. Now, what about if we're lucky, we got a 0 and we got a 1, but at the state C, the next import value is not 1. If it's not 0, if it's 0, then we got a 0, 1, 0, right? 0, 1, 0. So then we're going to accept that string. But if next one at the state C, the import is 1, now where are we going to go? So that means the string we are actually getting is 0, 1, and then once we got a C, state C, then we got another 1. Okay, so now the string going to start with 0, 1, 1. So no matter what the value is going to be after this string always going to start with 0, 1, 1. It's not 0, 1, 0. Okay, so then also we're going to land, if the value is 1, we're going to land at the E, which is trap state. So that means once we get into the trap state, there's no way that this string going to be accepted. Okay, so I think we're pretty much done, but let's first check, because for deterministic finite automata, we have to make sure for each state, we have to actually define the next state for every import value. So let's see, for state A, we have two import values, 0 and 1, right? So that means this is complete. Now for state B, we have 0 import 0 and 1. Each gonna goes to different next state. And for C, we have 0, import 0, we goes to D, import 1, we goes to E, so C is completed. For D, 0 or 1, it stays in D. For E, it doesn't matter whether it's 0 or 1, we stays at E. So that means this DFA is complete. And this DFA can accept strings that start with 0, 1, 0. Any string that does not start with 0, 1, 0 will be, rejected. It will eventually end up with state E, which is the trap state or dead state. Okay, so that's basically the answer for question 4. Okay, so let's look at the question 6. Build a DFA that accepts strings that start with 1, 0 or end with 1, 0. So that means we're going to build a DFA that accepts strings that either start with 1, 0, or if it's not starting with 1, 0 but end with 1, 0, or start with 1, 0 and end with 1, 0. In either of the case, the string going to be accepted. Okay, so let's actually start to build this DFA. Let's actually start with state A, which is a starting state. Okay. Now it's easier to build a string that starts with 1, 0. So if the current state is A, that means, and if the import is 1, then we are going to another state B. Okay. B is not accepting state, but it's one step closer to the accepting state, right? Because if the current state is B, that means the previous import is 1, right? So then we reach B. Now, if the next import is 0, okay, so then we have the string 1, 0, actually. So then we're going to accept this string, right? So we are going to the state C, which is accepting state. Okay. Now, once we are in state C, which is accepting state, the C means that the string actually starts with 1 and 0. So if the string starts with 1, 0, it doesn't really matter what's the follow-up imports, right? If it's 1, we still accept it because this string starts with 1, 0. If it's 1, 0, we still actually accept this because the string starts with 1, 0. Now, if it's 1, 0, 1, 1, we still accept it because it starts with 1, 0. So if it starts with 1, 0, it doesn't matter what's the follow-up import value. We always accept the string. So that means if we are at the state C, then it doesn't matter what's the follow-up import value. We stay in state C. Okay. Now, what about if we're in the starting state A, but import value is 0? Okay. So that means if the import value is 0 when we're at the starting state A, so that means the string gonna start with 0. Okay. If the string that starts with 0, that means this string never gonna start with 1, 0, right? So in order to make the string acceptable, then we have to make sure that string gonna end up with 1, 0. Okay, that's the only chance that the string gonna be accepted. So let's say if the import is 0, then we are going to the next state, D. If we're in the state D, that means the previous import value is 1. Okay. Now, in order to make sure the string eventually going to be accepted, then we have to make sure the next import should be 1, right? Then, which is one step closer to the accepting state. And then in the state E, that means the previous state import was 1. So then if we got 0 as an import, if the current state is E, then we got a string like a 0, 1, 0, and 0, 1, 0 is accepted, right? Because it ends with 1, 0. So we are going to the accepting state. But unlike these strings that the starts with 1, 0, if the string ends with 1, 0, it's very difficult to keep in the accepting state, because if 1, 0, 1, 0, that's accepted. But if we have another import 1, now this string is not accepted because it does not start with 1, 0, it does not end with 1, 0. But if we add one more 0, and the string going to be accepted again, right? So it's an end with 1, 0. So that means if the current state is F, which is accepted, but if we have one more import value, depend on the value of the import, then the string is no longer accepted. But if the import value is 0, then we have to build this string which ended with 1, 0 again. So we have to go back to D, so we can start to build the string that ended with 1, 0 again. Okay. Now, if the current state is F, but the import value is 1, then this is actually better than the other case, because if it's 1, that means we just need one more 0, then it's back to accepting state. So we can actually reroute to E, because in the state E, then if the next import is 0, then the string going to be accepted again. Okay. So now let's check. Now we have a state A, we have both import 0 and 1, right? 0 and 1. Now for D, we have, if the import is 1, we go to E, but what about import 0? If the import is 0, if the current state is D, import is 0, what are we going to do? So if the current state is D, that means the previous state is 0, import is 0. Now if the current is, so if we are in the state D, that means the previous import is 0. Now if the next import is 0 again, then in order to make it accepted, we have to, provide the next two import 1, 0. So that means we're not going to going anywhere. We're going to stay in state D. So hopefully the next two imports going to be 1 and a 0. Okay. Now if the current state is E, so if the current state is E, that means the previous import value is 1. So we just need one more import 0, then the string going to be accepted. So that means if the current state is E, if the import is 1, then we can stay at the E. So once the next one import is 0, then we jump to the accepting state. Okay. We're almost done. So the only state that we need to resolve is, let's see, B, right? Now B, for the import 0, then we're going to state C, but we haven't defined the next state for import value 1. If our current state is B, the import value is 1, what happens? So if the current state is B, that means the previous import is 1. Now if the next import is 1 again, so that means the string is not going to accept it, but it's one step closer to the accepting state, because if the next import is 0, then this string will be accepted because it ends up with 1, 0. So that means if the current state is B and the import is 1, we can move to E, because E is one step closer to the accepting state. As far as you get the next import 0, then it will be accepted. So that means if the import is 1, when the current state is B, then we're going to move to state E. So then it's one step closer to the accepting state F. So that's the answer for question 6. Okay, so let's look at the question 7. Now, let us build a DFA for language L, which is a set of all strings over 0 and 1 that don't contain the string 101. So now we're building a DFA that doesn't accept a string which contains 101. Now, to do that kind of problem, now it's easier to build another DFA. Let's say we're going to build a DFA, okay, for a language that accepts, string, accepts strings that contain 101. Now we want to build a string, build a DFA that accepts strings that don't contain 101. But first we want to build a DFA that accepts strings that contain 101. Now this is relatively easy to build. Okay, let's start with let's say A, state A. That's a starting state. Okay. Now, again, let's actually go through the easy path. Okay. Suppose the first import is 1. We got the state B, which is one step closer to the accepting state, right? Because we want to build a DFA that accepts strings that contains 101. Now we already have import 1. So if the next import is 0, then we're going to C. C is even closer to the accepting state. Now, if we're lucky enough, we build a string 101, then this is going to be accepted state, right? So if we are in the state D, then it doesn't matter what's the follow-up import. This string will always be accepted because it's always start with 101. So that means it contains 101. So it doesn't matter what's the follow-up string. So it's a 101, 111, it's accepted. 101, 011, that's also accepted because it contains 101. Now, what about if the in the starting state A, if the import is 0? Now, if the import is 0, so that means the first actually import is 0. So that means 0 is not really a good import because it's, if the first initial actually, the first import is 0, that means, this is not part of the string 101, right? So, but that's okay. We just want to build a DFA that accepts a string that contains 101. Okay. Now, if the next one import is 1, then we still can actually build a string that contains 101, right? So that means if it's 0, we don't need to give up. We just make sure that it stays in A until the next one is 1, right? Until, so if it's actually, for example, it's a state string is a 0, 0, 0, and then we're gonna stay in the state A, right? If it's 0, stays in A, 0 stays in A, so we always stays in A. Okay, until there's an import value 1. Then we move to state B. So if the next import is 1, that's good. So we are going to state C, which is one step closer to the accepting state. But what about if the next import is 1 at the state B? That's fine. We can stay at the B, right? Until the next import is 0, then we go to state C. Okay, so now if we are in state C, that means it's one step closer to the accepting state. But what about, if the next import is 1, then we go to accepting state. But what about if the next import is 0? Okay, if the next import is 0, so that means we have a situation that the previous import is 0, next import is also 0, right? Because C is coming from B, so the previous import is 0. So if the next import is 0, then we need to rebuild the string. We have to go all the way back to A, right? So we can actually restart the process of building 101. Okay. I think that's the DFA that accepts strings that contain 101. Now that's not the answer to our original question. Our original question is to build a DFA that accepts, a string that don't contain the string 101. Now that's relatively easy. Now how are we going to do this? Let's see. Let me actually first erase some of to free up some space. Okay. Now to build a string that don't contain, string 101, all we need to do is we reverse all the state. Okay. Now in this DFA, A is not accepting state. So when I say reverse, I mean if A is not accepting state, then we make it accepting state. We make the B accepting state. We make the C accepting state. Okay. Now these accepting state in this DFA, right? But for our answer, the D is not accepting state. So now we're going to keep all the data import value 1, 0, 1, and 0, 1, and 0, 1, 0. Okay. Now that's the answer. So the starting state A is not accepting state. Now if we, got import value 1, we go to state B. B is not accepting state because B contains only one, right? One, it doesn't contain string 101, right? So the only, state that we don't accept is D, because once we reach D, that means the string contains 101. So that's not the accepting string, right? So actually that's the answer for question 7.